So let's see, how do we prepare from alkanes? So here we prepare the halogenation using the alkanes with a mechanism. That mechanism is called as the free radical mechanism. Any idea what is free radical mechanism? What is radical? Any idea? So atom or molecule or ion which has unpaired electrons in its outermost shell. Simply to say, radical, nothing but an ion. Okay, it can be the positive ion or negative ions. Okay, so remember, for a radical, there are unpaired electrons are present in the outermost shell. And I said, whenever an atom or molecule or ion which contains unpaired electrons, it will remain as a very less stable. Yes or no? So whenever an atom is present as an unpaired electrons in its outermost shell, it will be very less stable. In order to get the stability, this atom will undergo bonding. And remember, in this method, we can get a different types of alkyl halides. It can be the monoalloalkanes, or it can be the polyalloalkanes. That means either one halogene is attached or many halogens are attached to the alkyl group. Okay, it can be Rx or it can be. So remember, it can be one halogen can attach or it can be many halogens can attach. So the product we get here, it can be monoalloalkanes or polyalloalkanes. So let's see how does this will happen. So remember, what is free radical mechanism of halogenation? Okay, it's a reaction where an alkane reacts with the halogen like chlorine or bromine to produce a halogenated compounds like alkyl halide and hydrogen halide. Hydrogen halide can be, it's an acid, HCl. Hydrogen and halide. Okay, alkyl halide. That means alkyl group with some halide. And remember, we are using chlorine or bromine. You may have question. So can we also do with fluorine, iodine? Is that possible? Free radical mechanism for fluorine and iodine? Yes, absolutely it's possible. But then why we are not using the fluorine or iodine? Why we are using only the chlorine or bromine? If you see the reaction order, fluorine is most reactive compared to the chlorine, and chlorine is most reactive compared to bromine, and bromine compared to iodine. And if you see, the most reactive is fluorine and the least reactive is iodine. So we are not using the most reactive and we are not using the least reactive halogen. They can react, they can participate in the free radical mechanism, but we are not doing with fluorine or iodine. The reason is, if we use fluorine, it is extremely reactive, so it can cause even the explosion. It can very less practical because it's most dangerous. It's a very explosion, so it can create a very hazard danger. Whereas iodine, it's a least reactive, so it cannot participate voluntarily. You need to produce or provide the energy in order to make the iodine participate in free radical mechanism. So remember, iodine requires energy, so it comes under endothermic. That means you need to give energy. You need to supply energy so that you can make the iodine to participate in the free radical mechanism. So it's a lazy guy. So without having energy, it will not participate in the reaction. Whereas the fluorine, you don't even need energy at all. It's the most reactive. It is very, very extremely reactive. So that extreme reactive can cause explosive. So that's why it is, as it is very dangerous, we will not use the free radical mechanism for fluorine. So then we left with chlorine or bromine. They are intermediate, so we can use them for free radical mechanism. Understood? So remember, fluorine and iodine, they can participate in free radical mechanism, but their behavior is somewhat significantly different compared to the chlorine or bromine. How it is different? One is most reactive, the other one is least reactive. It can cause the explosion. It can supply energy so that it will participate in the reaction. So that's why we will not do the free radical mechanism for iodine and fluorine. We will be using for chlorine and bromine for preparing the alkyl halides. Is that clear? Please tell me yes if everyone understood why we are not using the fluorine or iodine and preparing the alkyl halides by using free radical mechanism?
Yes.
Please, guys, respond. Okay. So how does this reaction will happen? This is okay. You just understand, but this is not very important for IP, but it is very important for NEET. So this is free radical mechanism is a chain reaction, and it happens in 3 steps. So step number 1, we call it as the initiation. Step number 2, propagation, like continuation. And step number 3, ending the process. So termination. So remember, it happens in the 3 steps: initiation, propagation, and termination. So let's see what is initiation. So what happens in the initiation is you are taking any chlorine molecule or you are taking any bromine molecule. So that is Cl2. So in presence of the ultraviolet light, that means you are supplying the energy so that it will be breaking down into the ions, 2Cl plus. Okay. So what we are doing in the initiation, it is we are taking the halogen molecule and we are exposing to heat or we are exposing to light, usually the ultraviolet light, and we are breaking the bonds between the chlorine molecule. So whatever the bond is present between the chlorine molecule, we are breaking that molecule, that bond, and we are turning this into Cl plus and Cl plus. Understood? So you are getting 2 chlorine ions, or you can say this is the 2 chlorine radicals. So remember, this is set as 2 halogen radicals. So step number 1, that is initiation. In the initiation, what we are doing, we are breaking the bond between the chlorine molecule and we are making 2 chlorine radicals or 2 halogen radicals. So in the initiation, we are synthesizing halogen radicals. So once we're done with that step, next we'll follow with the next step called the propagation. So what we do in the propagation? So whatever the radical that we got, the chlorine radical, it will react with the some alkane group. So let's take some alkane group, methane. And it will break the bond between one hydrogen and the carbon, and it will helpful for attaching that hydrogen to the chlorine. So whatever the CH4 is there, it is having hydrogen bonds. It is having bonds with hydrogens. So in that, you will be breaking one bond and you are taking this hydrogen and attaching the chlorine. So let me take, okay. So you are breaking the bond between one hydrogen and the carbon, and you are attaching this hydrogen to the chlorine radical. Okay. So we are attaching to the chlorine radical. So that will result in CH3 plus Cl minus. Or you can say that Cl HCl. Okay. So see here, whatever this hydrogen I have broken here, that hydrogen is making bond with the chlorine and it is forming HCl, which is nothing but hydrogen halide or hydrogen chloride. Okay. So remember, step number 2, we are making hydrogen halide and we are also making alkyl radical. So what is alkyl radical? This CH3 plus is called as the alkyl radical. And this HCl is nothing but hydrogen halide. It can be HBr as well. If it is bromine we are using here. As we are using chlorine, it's a hydrogen chloride. So step number 2, propagation. What happens in the propagation? We are preparing the alkyl radicals and we are synthesizing the hydrogen halides. Okay. And this, whatever the newly formed alkyl halide is there, this will react with the chlorine molecule that is present. Okay. So whatever the free radical is present, the CH3. So that CH3 free radical, it will break the bond between the chlorine molecules and result in formation of alkyl halide and chlorine radical. Okay, you can put as plus as well. So what happened here? So whatever we got the newly formed alkyl radical that reacts with another chlorine molecule and it will form allogenated alkane, or you can say alkyl halide. Okay. And this reaction will continue further, and many alkyl halides will produce. So that's why it is called as the chain reaction. So remember, the propagation can continue for many times, can continue for many times. So that's why it is called as the chain reaction. So remember, so whatever this alkyl halide we are producing by the newly formed alkyl radical, breaking the bond between the chlorine molecule. So this will continue for many times and form the chain reaction. Okay. Is that clear? So what happens in... Yeah,
I didn't
Nitya?
understand the step.
Okay.
I didn't understand the step.
Okay, see here. First, what happened in the initiation? We have a chlorine molecules. So when these chlorine molecules exposed to the light, or when you supplied some heat, it break the bond between the two chlorine molecules and result in formation of the chlorine radicals. Yes. So then what happens? These radicals, they react with the alkane group and they will influence the breaking of the bond between the carbon and the hydrogen. So when the bond is broken between the carbon and hydrogen, the hydrogen will attach to the chlorine. Okay. So that will result in formation of the hydrogen halide. And whatever this CH3 is there, now this will be the new alkyl radical, which is just wandering in the atmosphere or in the reaction center. So now this alkyl radical, which is newly formed, that will influence the chlorine molecule to break the bond between them. So before, what happened? We supplied the ultraviolet light, or we supplied energy to break the bond between the chlorine molecule. Now here, this free radical will influence the molecule to break the bond between the chlorine and chlorine. So this chlorine will break the bond, and one chlorine will attach to this. The other chlorine will just present like leftover. It is wandering in the reaction. Understood? So that's how we will get the methyl chloride. And this reaction, whatever this reaction happened, the propagation, this will continue for many times, and you will be getting many such CH3Cls and many such Cl ions. Understood?
Yes, sir.
Okay. Does anyone have doubts so far? Tanu, you got it?
Yeah, no.
Okay.
Got it.
So the last step is the termination. So what happens in the termination? So as you can see, termination, that means you are ending the process. How do we end the process? So why does the reaction has started? By breaking the bond between the chlorine and chlorine. Yes. So the reaction has started when you break the bond between the chlorine and you created the halogen radicals. So if we take out these halogen radicals from the chemical reaction, then the chemical reaction will not happen. So that's how you will be terminating the process. So how do we do? Whatever the chlorine radicals are formed, those chlorine radicals, they will turn out to be the chlorine molecule. Okay. So that's how you will be terminating the process. Not only that, whatever the free radicals present here, first suppose CH3 plus is there, alkyl radical, it is also reactive species. Cl, it is also reactive species. Remember, the radicals are very reactive species. So if they present in the reaction, they will make the reaction continue. In order to stop them, we need to prevent the radicals to convert into the molecule. So whatever the radical chlorine is there, I converted into the molecule. Whatever the alkyl group is there, I converted into the molecule. So the same I'll do again and again. So if I have these radical CH3 more, I will convert into C2H6 ethane. So I removed all the radicals in my reaction. I converted them into the molecules. So there are no reactive species in my reaction. Okay. So at the end, if you want to say what happened in the reaction, that's nothing but you are taking a methane. That methane is reacting with an halogen in presence of the ultraviolet light, and that is converting into the methyl chloride or alkyl halide and hydrogen halide, HCl. So this is the reaction. And if you see the mechanism, this is the mechanism. So just remember the mechanism. They can ask even for 3 marks or 4 mark question, and they can ask questions as well. So what does the alkyl radical do? So what does the hydrogen halide will do? So what is the UV light? How does the chlorine bond is broken? So what is chain reaction? Where does it happen? It happens in the propagation. So the questions can ask from anywhere. Okay. And remember, this free radical mechanism we use in the industries. We use in the industry for preparing the halogenated compounds. See, this has to be control mechanism. Otherwise, the reaction can happen more and more. So that's why you need a lot of equipment. Those equipment can available in industry. So you need industrial equipment. So remember, the free radical mechanism where you are synthesizing the alkyl halides, it should be prepared in the industries. Okay, remember that one. Is that clear? And remember, we cannot use the fluorine or iodine, fluorine and iodine by using free radical mechanism, because fluorine is extremely reactive. And on the other side, iodine is least reactive or very less reactive. So you need to supply the energy to break the bond. Okay, so you need energy to break the bond between I and I. So that's nothing but the exothermic reaction. Whereas here, it's extremely reactive. So it is very difficult to control. Second one, it is very explosive. Okay. And it's a very extreme fast reactive. So practically, it is very dangerous. Okay. So let's see one of the example. So CH3, CS2, CS2, CS3. So in the presence of chlorine molecule, ultraviolet light or light energy, so you are getting two different kinds of molecules. Why? So the chlorine can attach to here, or the chlorine can attach to here or here. Okay. So you can get two different compounds. If it is attaching at the terminal, you can get like one chloro. If it is attaching at the middle, you can get like 2 or 3. So you will be getting two different types of compounds. So one compound is, so CH3, CH2, CS2, CS2, which is attached at the terminal, Cl. The second one is CH3, CS2, CH, CS3, which is attaching here. So now the question is, which one will be the major product and which one will be the minor product? So for that, you need to know, so what carbon here and what carbon the chlorine attached here. So tell me, what carbon the chlorine attached here?
Primary carbon.
Yeah. So this is primary carbon, whereas here secondary carbon.
Secondary.
So which one is most reactive?
Secondary.
Secondary. So the reaction order, we know tertiary is greater than secondary, then primary. So this will be the major compound, and this will be the minor. So remember this. So the major product is secondary radical, okay, which is also more stable. And this pathway is more favorable. So more favorable for synthesis. Whereas here, less stable and less favorable. So that's why this will be formed as the minor product and this will be formed as the major product. Okay.
Sir,
Yes.
are both the products formed every time?
It depends. For suppose you take only, let's say you take only this one. So in this condition, if the chlorine is attached here, or if it is attached here, doesn't make any difference. So only one product is formed. But when you have unsymmetrical, like this, you can form many products. So that will be also a question we'll see. Okay, so what will happen with the different alkanes and alkenes? Okay, Nitya?
So there's only one carbon chain. So how will it form like two products at a time?
Yeah, it will form. First, suppose the chlorine is attached on the first primary carbon, and the chlorine can attach on the secondary carbon. The chlorine has two possibilities. Either it can attach here or either it can attach here. So it can form two products. First, suppose you are using 100 molecules of this and you are using 100 chlorine molecules. In that 50 molecules, you will be getting this product and 50 this. Let's say this will be performed as the major product. So you will be getting this as a 70
Okay.
and this will be as a 30 molecule. So that's how you will be saying 70 plus 30. So that's a major and minor product. Understood? You have the possibility where the chlorine can attach. It can attach on the primary carbon or it can attach on the secondary carbon.
Okay, sir.
And remember the rate of reaction. I told you the fluorine will be very, very extremely reactive compared to the chlorine, compared to the bromine, and compared to the iodine. So iodine is the least reactive. And if you see the reactivity of the hydrogen, the tertiary is greater than secondary, then greater than primary. Okay, so that's how you will be having the tertiary as the major product, secondary and primary as the minor products. Okay, so remember, yeah, 1 second. This will be the major product always, and this will be the minor product. So we'll be seeing two conditions. One is whether we are using the chlorine or fluorine or bromine or iodine. If the reaction happening with chlorine or bromine, which one will be formed more? Then chlorine will be formed more because the reaction with the chlorine is more. And if it is given with the tertiary, secondary, primary carbon, the major product will be the tertiary carbon. Okay, and the minor product will be the primary carbon.
Yes, sir. Done.
Okay. So now try to answer this. So try to answer this. What could be the option?
Sir, option B.
Option B. Okay. So gaseous hydrocarbon X on reaction with the bromine in light forms a mixture of two monobromoalkanes. So that means he is saying that we'll be getting two different types of alkanes. So what could be the possibility here?
Option C.
Okay, yeah, it is the option C. Let's see how does this happen. For suppose let's say the CS3. Okay, so in presence of the bromine and light energy, ultraviolet light. So what is the option? Here the bromine will break and it has to attach with either this carbon or this carbon. So you will be getting CH3Br. So whether it is attaching to this one or this one, both are the same compound. So here you are just getting only one product. So the next option, you see this one. So after breaking with the bromine, now where does the bromine can attach? First, it can attach at the end. So here, or second, it can attach here. So let's number it. So 1, 2, 3, 4, 5. Okay. So it can attach on 1, or it can attach on 2, or it can attach on 3. So there are 3 different ways. So you can get 3 different products. So one is this. Second one is you can get here, or you can also get here. So how many products do we have here? 3 products. So this will be not my option. This will be, so A is not my option. B is not my option. Because I said, what is the question is asking? We need to get 2 products. But here, 1 product, here 3 products. So both are not my options. So let's see C. So the C will be upon reacting with the bromine, we break the bond and 1 should attach. So what is the option do we have? So now this 1, 2, 3. So I can attach my bromine on 1, or I can attach my bromine on 2. Okay. So in that case, I'll be getting so in this case, I'll be getting my bromine attached here, or my bromine attached here. So how many products I get? So this is 1, this is 2. So I got 2 products. So this option is C. So the question is asking 2 products. So I got this. Now I have a D. So D can make many products. There are many possibilities are there. So where is my carbon, 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 carbon? If you have a doubt with the line this way, you can write carbons instead of. So what are the possibilities now? I can attach my carbon here, sorry, my bromine here. I can attach my bromine here. And I can also attach my bromine here. And I can also attach my bromine here. So how many possibilities are we getting? So total 4. So there are 4 different possibilities. So I'll be getting 4 different products. So this is also not my option. So the option is C. Understood? Nitya?
Yes, sir.
What about everyone? Dia? Are you in the
Yes,
class?
sir. Yes, I am.
Okay, you're getting this?
Yeah, I am.
So now this one, the number of possible enantiomers that can be produced during the monochlorination of 2-methyl butane. So what is meaning of enantiomers? That is nothing but different kinds of products that can form from a single structure. For suppose you take all this. So what is this? This is nothing but C3H7Br. But I can write C3H7Br in 2 ways. One is this way or this way. So from a given structure, how many possible ways you can form a product? That's nothing but the enantiomers. So here is asking monochlorination of 2-methyl butane. So what is meaning of 2-methyl butane? Butane, so 4 carbons. On the second carbon, there is a methyl group is there. That's what mean 2-methyl butane. So there is CS3 here. So how many possible ways I can make a product? How many different types of products I can make? I think this looks like the previous one, right? So this one. You can see here. This is same product. What is this? There are 4 carbons, and on the second carbon, we have a methyl group. So nothing but 2-methyl butane. So how many products I got here? 4 products. So what will be my answer? It's option B. Is that clear for everyone? So why I choose the option B here? So 1, I can attach my halose here. I can attach my halose here. I can attach my halose here. I can also attach my halose here. So total 4 different ways I have. Okay, you can, this one and this one almost the same. So here actually, okay. So I can attach on my first carbon. Here the first carbon can be this or this. based on how you will take the numbering. So for suppose this can be the numbering possibility. In that case, I'll be getting this as my methyl group. If I take this order, this will be my methyl group. So I can attach on the first carbon, second carbon, third carbon, fourth carbon. So I can get 4 different products. So let's see now, how do we prepare using the alkenes? Okay. So what are alkenes? They are nothing but the carbon chain with double bond. So here you can synthesize in 2 ways. Okay. So remember, alkyl halides prepared from alkenes 2 ways. So one, you can use mono haloalkanes, or you can get dihaloalkanes. So for getting mono haloalkanes, you need to use the addition of HX. That means we are reacting with hydrogen halide. Whereas here, we will be reacting with the halogen molecule. So addition of X2. So here you can use HCl, HBr. Here you can use Br2, Cl2. So that's how you will be preparing in 2 different methods. Okay. So when you are using addition of X2, so you are having 2 bromines, 2 chlorines, so you can get dihaloalkanes. But here you are having only one halogen, so you will get monohaloalkanes. Okay. So one second, guys. Sorry, this is not haloalkane, it's a alkene. Okay. So let's see, how do we prepare using the HX? Let's take the example CS2 double bond CS2. So when you react with hydrogen bromide, so when we are reacting with hydrogen bromide, we are getting one type of or 2. We are getting monohaloalkanes or dihaloalkanes.
Mono.
Yeah, we are getting here the monohaloalkanes. That is, so you are breaking the bond between hydrogen and bromide, and you are attaching one hydrogen to one carbon and one bromine to other carbon by removing the double bond here. So the double bond will be broken and it will be converted into CS2HBr. So how does this will happen? This will convert into H plus Br minus. And here, whatever the double bond is there, it was given to one atom. For suppose, let's say this double bond after broken, it will be given to carbon and the other one will become positive. So one will become positive, the other one will become negative. So when it is positive, the bromine is negative. So they both get attached and bromine will attach to one carbon. And the other one is negative. Here, proton is positive. So the proton or H plus will come and attach to the CS2. So that's how it will form monohaloalkane. Okay. And how many products you got here? You got only one product. So that will happen when you are taking the symmetric. So remember, this will happen only when you take the symmetric alkene. What is meaning of symmetric alkene? That means whether I attach my hydrogen here or bromine here, or bromine here and hydrogen here, so that will give same product. So that's called as the symmetric alkenes. Okay. Asymmetric means when you have more than 2. Okay. So suppose you can consider like all the odd numbers will be the asymmetric, all the even numbers will be symmetric. Okay. So let's see the addition of HBr on unsymmetric one. So unsymmetric alkene. So what happens here? The CH3, CH double bond CH2. When reacts with HBr, it can form two products. One is it can form the CH3, CH2, CH2, and bromine here will attach to the final carbon or the first carbon, or the bromine is attached to anywhere in the second or third. So that will be CH3, CH, CH3, bromine here. Okay. So now we got two different kinds of compounds. So let's say this is left and this is my right. So tell me which one will be the major product and which one will be my minor product? So which one will be my major and minor product in
Right
this?
one major, left one minor.
What about the others? Okay. So see here, what is the reactive order? Secondary, primary. So in this, which one is the let's say this one is my primary carbon and this one is my secondary carbon. So according to this rule, the secondary carbon is more than the primary. So the right one will be the major product. So this will be my major product and this will be my minor product. This is very important for CBSE board as well. They can give the reaction and they can ask which one will be the major or minor product, because you guys have 18 marks as MCQs. So it's also very important for board. So that's how we'll be preparing by using hydrogen bromide or hydrogen chloride. Now let's see how do we prepare by using halogen molecule. That is the addition of X2. It could be the Cl2 or Br2. So remember, we are not taking the fluorine or iodine. We are taking the Cl2 or Br2. Okay. So let's see one of the example here. The carbon double bond. It's having hydrogen, hydrogen. So when I use the bromine, so what happened? Br2. The bond between the Br and Br, it will broke. And one will attach to one carbon, the other will attach to the another carbon. So which will result in forming the product CH2, CS2. CS2, CS2. So this double bond will be broken and each bromine will attach. But how does the bromine will attach? Will attach on the same side or different side? It will attach on the different side or opposite side. So remember this. So this mechanism, we call it as the anti-addition mechanism. So this is called as the anti-addition mechanism. So what does this mechanism says is, in a chemical reaction where two substituents are added to the opposite faces of the double bond or opposite sides of a double bond, that reaction is called as anti-addition reaction. Okay. So what is anti-addition reaction? So the chemical reaction where two substituents. So here my bromine, this bromine and this bromine, they are two different substituents that are added to opposite faces. Or you can say the opposite sides of a double bond or triple bond. That we called it as anti-addition. And remember, this type of compound is also called as the vicinal dihalide. It is also called as the vicinal dihalide. So remember, in organic chemistry, wherever you see the word vicinal, it means the neighbor carbon. So remember this, it is called as two substituents. So what are two substituents here? The bromine. Okay, these bromine are attached to the two neighbor carbons. So let's say 1 and 2. So both are neighbor carbons, side by side carbons. So when molecules are attached to the side by side carbons, we call it as vicinal. And here, what molecules are attaching? The bromines are attaching. So they are called as vicinal dihalide. Okay. So two substituents are attached to two neighboring carbon atoms. In a carbon chain. So that's called as the vicinal dihalide. So remember this. Okay. So this mechanism is called as anti-addition, where the bromines are attached to the opposite side. And second one, this compound is called as the vicinal dihalide, where the bromines are attached on the neighbor carbon. Okay. And remember, this type of addition, we call it as electrophilic addition reaction. So addition of halogens to alkenes, this reaction is called as electrophilic addition reaction. It is called as the electrophilic addition reaction, because we are synthesizing an electrophile and we are attaching that. Okay. And remember, when we are doing this electrophilic addition reaction, it involves aluminum ion formation. Okay. So this will involve aluminum ion formation. So what is this aluminum ion formation? What is it? So let's see. If you want to get into detail of this, I'll tell. Otherwise, this is not needed. Just this is for basic understanding. That will make your reaction somewhat simple. So actually, there's a mechanism of electrophilic addition of halogens to alkenes. I mean, how this entire reaction is happening. So this like the reactants are undergoing reaction and we are getting product. But what is the mechanism behind? I'll just tell you. It's okay if you remember or it's not needed, but just listen. Just have a basic idea. So first one, how does this reaction will happen is, it will happen by formation of an electrolyte. Okay. So first it will start with the formation of electrophile. So remember, we have two different things. One is electrophile and the other one is nucleophile. Remember, in chemistry, phile means love. Phile means love. So those are electrophile, those loves the electrons. So remember, in chemistry, electrophile means those which love the electrons, they are called as electrophiles. And we have a nucleophile. So those which love the nucleus or protons or positive charge, we call it as nucleophile. So remember, electrophile, which love the molecules which love electrons. So generally, which molecules will love electrons? Does the electrons love electrons? Does the negative charge will love negative charge? We know the universal law, always the opposite charges attract. That means here the negative charge, the electrons, is loved by the positive charge. So electrophile, it is nothing but the positive charge which loves the negative charge. Okay. So you can say, what is the charge of the electrophile? It's the positive charge. And this positive charge molecule will love the negative electrons. So that's called as electrophile. And the opposite goes for the nucleophile. So nucleophile, which loves the nucleus or which loves the positive. Love electrons. Okay. Which love the positive. So generally, these will be the negative molecules. So these are negative molecules. So they love the positive molecules. Okay. So remember, nucleophile is a negative molecule or negative ion or negative atom. It loves the positive molecules or positive atoms. Whereas electrophile, it's a positive one which loves the negative electrons. Okay. So we are forming the electrophile. That means we are forming a positive ion. Okay. So that's happened with a halogen molecule. So this takes place with a halogen molecule. So let's take an halogen molecule, bromine, bromine. Okay. So when this bromine molecule, when it comes near to electron-rich alkene, electron-rich alkene, it will turn out to be the radicals. So one will be having slightly positive, the other one will be having slightly negative. So the bond will broken, and here the bond will be taken by, the electrons present in the bond will be taken by one. So that one will get the positive charge, sorry, negative charge. And the one which lost the electrons in the bond, that will turn out to be positive. So remember, let's say the molecule A and B. There is a bond between the A and B. So that's a bond is nothing but participation of two electrons. So when this bond is broken, actually each one electron should go for A and B. But what happens here? So when the bond is broken, both the electrons will be taken by one atom. So that will be turned out to be the negative atom. And the one which lost the electron in the bond, that will turn out to be the positive atom. So here the bromine will be slightly positive, the other bromine will be slightly negative. So this type of interaction, we call it as the dipole interaction. Okay. So this is called as dipole, as there is a two polarity are formed. Okay. So this is called the dipole. Okay. So remember, how does this dipole is formed? The electron rich alkene will induce the dipole, in halogen molecule. It will induce the dipole in halogen molecule. So you understood what is meaning of inducing the dipole in halogen molecule. That means you are making partially positive and partially negative. Okay. So here we are inducing the dipole. That means we are partially making the positive, partially making the negative. And what is inducing here? The electron-rich alkene. So whenever this electron-rich alkene comes near, that will break the bond between the bromine and bromine, and it will turn out to be slightly positive and slightly negative. So this is called as the formation of the electrophile. Okay. So next, what happens next? The second step is formation of cyclic halonium ion. Formation of cyclic halonium ion. It's okay. You don't need to remember all this. Is not that much important. Just you should have a basic idea. Okay. So how the bonds are breaking, so that the organic chemistry will become very easy. So how does the bond is broken here, bromine and bromine? Why one bromine is attached to the other one? Why it is positive? Why it is negative? It is very important. This is not much needed, but you just have a basic idea. So what is meaning of formation of a cyclic halonium ion is, you take a alkene molecule. So this alkene molecule, you take this alkene molecule, which is CH2 double bond CH2. So when it comes close to the bromine molecule, so when it came close to this bromine molecule, what happened? It induced the dipole in this bromine molecule. That's how one converted into the partial positive, the other one is converted to the partial negative. So in that, the double bond will be broken here, and one bromine will attach here. So that will turn out to be CH2, Br, and CH2. So this entire molecule is somewhat positive. So we called it as the halonium ion. Okay. So whatever the double bond alkene is there, when it came close to the bromine, it induced the dipole in that bromine molecule, and it made the bromine molecule to break. And when it is broken, that bromine radical will attach to one of the carbon in this alkane group. So when it is attached, it slightly turns out to be the positive. So that's the formation of the cyclic halonium ions. So remember here, what happened here? There is a positive halogen atom, that is Br plus. Okay. So this Br plus will slightly attack the pi electrons present in the double bond. Okay. So when it attacks the pi electrons present in the alkene, that will break the double bond here, and it will convert into a single bond. When it converts into single bond, the carbon has the capacity to attach with someone. So this bromine will go and attach to that carbon and result in formation of a halonium ion. It's a three-membered ring. It's a cyclic halonium ion. It's a three-membered ring. So that's okay. You don't need to remember the structure. Just remember what is meaning of halonium ion. Okay. So then what happens is, this will continue with the last step, that is nucleophilic attack. So what happens here? Whatever this ion is formed here, now this will be attacked with a nucleophile. So what is meaning of nucleophile? Something, the negative ion, which loves the positive ion. Actually, this is a positive ion, right? So this is a positive ion. So we got two different ions. One is the positive, the other one is negative radical from the halogen. So this is a negative one. So we call it as this one as nucleophile. And this is a positive one. We call it as the electrophile. So this electrophile, let's take the A is electrophile, B is the nucleophile. So what does the A do? A is went to the alkene group and it broke the double bond here. So let's say this is A. So the A came to the double bond and it broke the pi electrons present here and it attached to one carbon. When it is attached to one carbon, it converted into the positive halonium ion. Now there is also a negative nucleophile. It is roaming around. So that negative nucleophile, which is negative, and this positive ion, both are opposite in charge. So this negative one will come and attack this positive one. So that's what happens here. So see here, CS2Br, CS2, which is positive, and the negative bromine will come and attack this. So when it come and attack this, then you will be forming CS2Br, CS2Br. So that's how finally you got this from this. So this is the mechanism behind. You don't need to remember the mechanism. Just you should understand that the bromines will broke and it will convert into electrophile and nucleophile. One will attach to one carbon, the other one will attach to another carbon. That much is needed. Okay. So that's about how do we prepare the alkyl halides using the hydrocarbons. And then we'll see allosin exchange. Okay. So we'll stop here. We'll continue that in the next class. Okay. Is everyone understood?
Yes, sir.